So welcome to Intro to HPC. I'm Marcelina, and this is Ja, and we'll be presenting what high performance computing is. So our agenda for today is what is the Research Computing Center, what is high performance computing, and we'll talk a little bit about high performance computing definitions, as well as how to access HPC, any support that the RCC team can provide. And then further on, we'll talk about more of exercise and hands-on sections so that you can have a little bit of experience yourself. Like I said before, I'm Marcelina Nogales. I'm the manager of the Research Computing Center Software and Applications team. And then Ja will be presenting later, and she's an application specialist at RCC as well. So the Research Computing Center, RCC, is a unit of FSU IT. We used to be a division of scientific computing before 2013, and we host and administer the main supercomputing resource at FSU, the high performance computing system. So you'll see HPC and high performance computing system mixed in to our presentation and talk, and that's what I'm referring to. So these are the stats specifically for our system here at FSU. We have around 650 nodes, 71 GPUs. We're running everything on Alma Linux. We have 20,000 processors, both AMD and Intel, 518 teraflops, not including our calculations for the GPUs that we have, and then 29 million jobs submitted since 2008. So what is high performance computing versus really why high performance computing should be an alternative to regular normal computing on your personal laptop? You have a lot of options in terms of specialized hardware. So there's going to be more processors than the average home computer. There's you can have custom machines via a research grant and request specific specialized hardware, including like CPUs, SSDs, GPUs. As opposed to your personal computer that can only have either AMD or Intel processors, high performance computing can contain both, and you can use it depending on the software that you're looking for and you're using for your research. As I'm sure we've all had before, sometimes when we're using a software on our computer, it's the only thing running on our computer for like days or weeks, and we're not actually running anything else. So high performance computing is an alternate solution for that, so that way you can do any of your other like answering emails and stuff while also doing your research at the same time. High performance computing allows you to use parallel processes that you can technically use on your computer, but it plateaus in terms of efficiency and optimization at some point. And if you're batch processing tasks, so you need to like modify one particular parameter, or you're having to like do simulations for the same set of data over like a larger subset of data, this will allow you to run tasks repeatedly over a long period of time, as opposed to trying to do it one after the other. So that's why we do high performance computing, but really, how does that look on our systems? So whenever you are starting to run your data on the HPC, you start off with your own data and your program, which may require some software that we already have on the HPC. We send that data to our compute nodes, and then out comes your output. So that's kind of a higher overview of like how this works. So the FSU's high performance computer is a shared resource. And so what that means is that when you want to run a job, it doesn't immediately start because we're sharing it amongst all of the researchers at FSU and even external collaborators as well. So what that means is when you're entering your data and your any sort of other input, that goes through the job scheduler, which allows it so that when people are entering their jobs, the cluster doesn't freeze up because everyone's trying to run their stuff at the same time. So that kind of gets sorted through based on your user account. So what privileges you have as a user within FSU's HPC, and also what Slurm accounts you have access to. And Slurm accounts, a way of thinking about it is that on a conveyor belt, you have different lines that you're kind of utilizing to get access. And a Slurm account is effectively a line or a queue that you would queue up. We have a couple general access ones that we'll get into later. There's also owner Slurm accounts, which will allow you to like only have your jobs on there, and so your wait time is less. And that's one of our paid services. But if you're using a general access one, you're going to be waiting in line with other users. But once the resources are allocated to your particular job, then you're free to have your output, and then you can do whatever you need to in terms of like analysis or exporting that data. So before we jump into how to access the HPC, does anyone have any questions on the general overview of how HPC works? Any online? Okay, perfect. And then I'll leave it to Judd to talk about how to access the HPC.
I think you have some idea about what is RCC, what is HPC, and from now on we can proceed with how we can access to the HPC system. So there are two ways to access to HPC. The first one is command line interface. HPC is built on Linux operating system, so it's quite natural and straightforward to use Linux command to access to HPC. But you need to have a command line interface, which you need to have a SSH supporting terminal, which is the secure shell terminal pre-installed on your computer to log into the terminal. And the language you can interact with the system is the Linux command. So command only. So this is something about command line interface use of HPC. Another way you can use HPC system is the graphical interface. And we provide open on demand. These provide users to access to HPC using the visual elements, which means that you can access to HPC from web browser, and then you just browse on the page and click the tabs and then submit jobs or edit files. And this is the graphical interface, just like what you did with your Mac computer or your Windows computer. And for this one, I'll talk about them in details later. So first, command line interface. As I said that you need to install a SSH terminal. What are they? So these are all the options you can choose to install. It totally depends on what kind of computer you have. For example, if you have a MacBook, you can choose iTerm. And if you have Windows, you can choose Windows PowerShell or Tactile or Bitwise, a lot of choice actually. And the one we recommended is Mobile Xterm. So this one is an application. It's kind of an all-in-one application. And with many, you can see here, with many remote network tools,
Sorry, can you hear me?
SSH, and you can secure shell to the terminal. And it has FTP and SFTP, that is for file upload and download. And one thing I think is convenient for you is that when you access it to the terminal, there will be a SFTP file browser here, automatically generated for you. So you can drag the files out and in for download and upload. That's quite convenient. So this is the one we recommended, but you can use whatever you feel comfortable with. And another thing is that, as we say that you need to use Linux command to interact with the system. So Linux command, some basic ones are good enough for you to access the HPC. So actually, RCC offers introduction to Linux workshop every year. The last one we held is in September. So if you are interested, check with us for the next one. Next one, graphical interface. As we say that we provide open on demand. Open on demand is an ongoing NSF project developed by Ohio State University Supercomputing Center. The aim of it is to allow users to access to the HPC system with minimum knowledge of Linux. And if you have a web browser, you can access to the HPC system. So that is quite convenient and easy for you to use. And as you can see here, when you log into from any of the web browser, you can see some of the tabs here. I will show you what are they shortly. And then you can edit files. You can view your files. You can upload, download files. You can delete your files, move your files, and you can submit your job, monitor your job, and you can also use the interactive applications here. These are all the GUI applications that you can use, such as MATLAB, such as Jupyter Notebook, and are a lot of choice. I think currently we have 18 graphical applications. So in conclusion, which way to choose to access the HPC system is totally depends on your need. If you want to use the graphical applications, Open on Demand is a good choice. And if you are quite familiar with the Linux command, you can use the terminal to access to HPC. So this is a basic thing about how to access to the HPC system. And this is the link of Open on Demand. We'll use that shortly. And this is the documentation. And actually on the right top of the documentation, there's a tab to link you to the login page. So this is something about Open on Demand. Any questions so far? Yes, please.
Like, is there any difference in the job wait time using a terminal versus using Open on Demand, or
I think no. Yes. Yes, please. Oh, actually, you do not need to apply for an extra account for that. If you apply for the RCC account, you can log in from Open on Demand and log in from the terminal. Use the same RCC account. I will talk about it later. Yes, Alex, please.
Just a question from online. Is it possible to ask for specific programs to be installed on RCC systems? Like if you have a specific requirement that you have, can you ask us to install it?
I think we provide hundreds of softwares and programs, but for some specific one, we can install that on your home directory. And please contact RCC support for details and check and talk with us. We'll try to help you to install that. Yes, any questions? No? Okay, let's continue to talk about how to submit your jobs to the HPC system. As Marcelina has already introduced that, we have a large amount of resources. I mean, HPC system has a large amount of resources, but the resource is still finite. And it's the shared resource, which means that all of the FSU users have to share the resource together. So how to do that? She has already mentioned that, how to do that? Scheduling, right? So the Slurm scheduler is the one we use. But how can you interact with the scheduler? How does the scheduler know that how much resource you want? So that is the things we're talking about shortly. So that is actually we need a job submission script to contact with the scheduler. And we'll talk about resource allocation in Open on Demand. For that one, it's quite easy because it's kind of fill the form and then the system will generate a script for you. And if you want to use the command line to submit the job, you need to write a job submission script and use any of the editors such as Vim, such as Nano, and whatever comfortable with, and then you can submit your job from command line. I will get started from how to do the resource allocation in Open on Demand and then the command line so that the learning curve will be not that deep. So it has a smooth learning curve to let you know how to do that, okay? Let's look at Open on Demand first. As I say that when you click the link, you will get to this page. And from here, if you enter your RCC ID and password, you will get on the landing page of Open Demand. today we have already give you the workshop account and password, right? If you want to try, just try to log into here, and from here you can see the tabs here. We have the interactive applications, and we have the file system, and you can check your active jobs, and actually that is the real-time data observation of all of the jobs on the HPC system. I will show you shortly. And you can also access to the terminal through the cluster. So this is the basic things about Open On Demand. And you can also check my interaction sessions where you can find all the jobs related to the system. If you don't delete it, they will be there. And I'd like to talk a little bit more about the file system. So this is the file system you can use. Just click the file, and then you will directly here. And from here, it is the home directory of your RCC account, which means that from here, you can view your files, edit your files, delete or move files, upload and download files. But please note that the limitation of upload and download files from this page, from Open On Demand, is 10 GB, which means that if you have larger files to upload or download, you need to use global some other things. And I have already provide the link of data transfer here. And for larger files, you need to refer to that. But for the files smaller than 10 GB, you can just upload and download from here. Make sense? Okay, that battery is running low. Okay. I will give you a demo here. Okay, so this is the Open On Demand. I will log out to show you. You can get it from here. If you have the workshop account, you can try and connect to Open On Demand. And from here, as you can see that we have the applications here. Those are the GUI applications you can choose from. And this is the file system. We have already mentioned that this is a home directory. And you can do all the file management here. And this is the active jobs. And you can see all of the jobs on all of the clusters. Is there anything wrong here? I cannot see any jobs here. Okay, let's look at the cluster access. So this is the RCC cluster access. If you click here, it will lead you to the terminal. So this is exactly the same that you can use with the terminal access. And this is the interactive jobs. And I'd like to, there are 18 of them. And just choose the one you use and then submit your job. I will go back to the slides and show you how to submit the jobs. So this is the resource allocation. When you click any of the applications, you need to fill the form to tell the scheduler know how much resource you want to use. So the first one is Slurm account. Slurm account, you can think of a set of computers that you want your job to run on. So typically, the general access Slurm account includes general X, backfill 1, 2, and counter and quick test, and these are all the ones you can use and choose. Today we can use workshop to see. And the other thing is that if you belong to any research lab, for example, EOAS, if you belong to engineering queue, you can use your specific queue. And if you want to buy a specific queue for your research lab, you can talk with us about it. And this is the maximum number of time you expected for your job. And typically, if you choose different queues, the maximum runtime for each queue are different. For example, general queue has 14 days of maximum time, while backfill 2 has 4 hours. So, which totally depends on how much time you want to run your job. And we are back. Sorry about it. It's out of power suddenly. And let's talk about the resource allocation to submit the job. So, we'll stop at here to talk about the hours, the time you'll use for your job. And this is the maximum amount of time you expect it to run. So actually, the thing is that the longer you put here, the much longer time you will wait for your job to be scheduling. If that makes sense. So just choose the enough time for you to run. It's not always the more the better. So, and the next one, we'll talk about this is the amount of memory. So please note that this is the total amount of memory, which means that it is not the memory on specific queue. This is the total memory you need for your job. So in that case, you need to put enough memory here. And please note that you must include the gigabyte here, the G here, which means because the system is the default unit is megabyte. If you do not include G here, it will give you only 16 megabyte. Make sense? Next one. This is the node. You can think of node as an individual computer. And so for most of the applications on open demand, it needs one node. And this is the number of cores for your job. For this one, you need to include the total number of cores you want to use for your job. And the maximum cost for each queue is listed here from this link. Okay? You can think of node as a computer, and you can think of a cores as the CPUs. So this is how you want your job to be allocated the resources. And this is the GPUs you want to use. And I think the maximum of GPU for many of the general access queue is 2. So this is, if you want to use it, just enter 1 or 2 here, or otherwise just leave it blank. And that will shorten your waiting time. Does that make sense? Okay. So I will show you how to submit a job. So can you see the interactive apps here? And from here, I will click RCC desktop. So this is one of the application we have. And here, you can see that we will choose from the Slurm account first. I will choose workshop for today. And the number of hours, I will choose 1 hour. And 16 gigabyte of memory. And the number of nodes is 1. And number of cores 16, for example. And then if you want to receive email about the session starts, you can click here, or otherwise just launch. And after you submit your job, you can see there is a blue something blue here. This means that your job has already queued, and now it turned green, which means that you can use your session from Launch RCC desktop, and this is the desktop you can use. This is the home directory, and this is the terminal, which has already get into the running node. And after you use this, turn off the And then if you want to delete the session, that should be fine. And if you want to leave it here, let it burn out, that should be fine as well. So another thing is that this is the job ID. If you want to troubleshooting with some of the things, this is the things you need to provide with us. And as we said that for job ID, you can also check here. Oh, no, it comes back. See that this is the active jobs you can check. And as you can see that there's a filter here. You can use your RCC ID, for example, to search a job. You can check about specific queues, for example, backfill 2. It will list all of jobs on backfill 2. And you can also use your job ID to search for your job. This is how you can do the search, and this is the real-time data. Okay. Any questions so far about Open on Demand and how you can submit your job to Open on Demand? No. Okay, let's continue to talk about the command line job submission. So as I mentioned that command line job submission, you need to submit a script to the system. So this is how the Slurm script looks like. And the basic syntax is like this. And let's look at the first line is, and you just keep it like this. And from the second line, this is means -G means the name of the job. You can name your job here. And the second line -A is the account you can choose. So from here, you can see that you did the exactly same thing as you did on Open on Demand, right? So you can choose the Slurm account you want to run your job and put it here. And this is the running time. Again, it's the estimated maximum time of your job. And you can, and please note that if you want to write that into the script, there is a format of the time. And the format is like this: a day, and then dash, and then hour, minutes, and second. So if I write like this, it means that 4 hours. And different queues have different running times. So you can check the default wait time here. And this is something about the running time. Dash memory is the total memory you ask for your job. And you can, if you have some idea about how much memory you want to use, you can include this line. And if you leave this line blank or you don't include this line, it's also fine, because the Slurm scheduler will allocate it memory like this. They will use the number of cores here and then times the default memory per core to allocate the memory. So which means that if you do not include the memory line, they will allocate it like this. But different default memory per core is different. For example, if we use backfill 2, the if you do not include the memory line, the memory you got is 16 times 3,900 megabytes, which is the default memory per core. It's roughly it's about 62 gigabyte, right? And if you use general queue, the default memory per core is 19. It is 1,900 megabytes. So which means that you will get half of the memory at this case. Make sense? And this is the number of cores you need to include it in your job script. And most of the benefits of HPC comes from the parallel processing. So you can increase the number here if your software supports the parallel processing. And this is the number of nodes. Again, you can think of node as computer and cores as the CPUs, and this is how you can ask for resources. And this is the number of GPUs. If you want to use the GPU, you can write this line here. Otherwise, you can omit this line. So as we have already talked here, do you have some basic idea about what is the difference of CPU and GPU? Yes, right. So for generally speaking, that if your job is kind of a serial job that requires logic, requires decision making, which means that if you're coding, you do a lot of if then else, do a lot of jumps, this kind of things, you need CPUs. For example, operating system, IO management. For example, if it's data, if data sorting needs a lot of CPUs, right? But the GPUs is different. It has thousands of cores for GPUs. For GPU jobs, such as for those parallelized jobs that requires repetitive, independent instructions for this kind of jobs, such as machine learning matrix jobs, and you want to do the neural networks training of data. So for this kind of job, or scientific simulation, so for this kind of jobs, you need GPUs. So that is the difference from when you want to ask for resources, right? And the next line is something about how you can module load the softwares into the job script. And for this job, we will demo it. You need to module load GNU and OpenAPI, and then you can let the computer know that I want to run the job. Since it is a non-interactive job, you need to let the computer know that I want to run it. So the last line here as run, and then this is the executable file that you can run. So this is the whole job submission script looks like. Let's take a look in conclusion that if you submit the script to the system, it will let the system know that I have a job named my job, and I want to run it on backfill 2 and for 4 hours. And the total memory I want is 16 gigabyte. And number of nodes I want is 16. This is the CPUs. And I want to run it on 1 node and 1 GPU. And before that, I module load GNU and OpenAPI, and I want to run my job called example.x. So this is a basic thing about command line job submission script. And let's do, if you want to submit that from command line, what you should do is that you need a terminal to log in to the HPC system. As I said that, the one I use is the mobile app term, and I will use workshop as and as you see that we have already provide you with 2 of the files here, and the example .x is executable one. I will show you how to do that later. But now I want to show the demo using this one. So here, you need to write a script using any of the editors. So here I use Vim to do the demo sh. And let's see. So this is the basic things about the job script. I think what I make changes is the workshop. I changed from backfill to workshop account, and I changed the time to 1 hour, which will shorten our waiting time. And this is the memory we're going to show. And I do not need to use GPU for this job. So I just comment out this line, and let's try to submit the job. The batch and then demo.s. This is how you can submit your job to the system. as you submit it, you can see that here shows submitted bad job, and this is the job ID. Can you see it? Yeah, and then yes, after it has already got the result, and the result will be here, Slurm, and then your job ID, and then out. Let's see. This is the running result. And you have submit your job to the system and you got the result. So this is pretty quick. And for some of the large data, you may wait for days and hours. And for that one, you just submit a job and you can do whatever things on your own computer. You don't need to take any CPUs, memories from your computer. Just submit the job to the system and you can do your work on your own computer. So this is the benefit of HPC system. Any questions so far?
So I know that the way that Ja showed you how to create the submit script was through the terminal. But the expectation is not that you already have like the experience with Vim or Nano or any of the ones the terminal. A way that you can also enter the same information is if you go to files in Open On Demand. You can create a new file here and just type in the name of the file. So for example, that was like demo.sh, but I'll do demo2 just in case we already have a demo. And then once we create that file here, you're able to edit it from on demand and kind of paste that same, paste all that same information, save it, and then you should be able to run it from that same way through SBatch, which will that Joe will get into in a little bit.
So she means that if you are not familiar with the Linux editors, so if you are not familiar with that, you can do from Open On Demand. So this is a backup solution for editing the files.
Right. So the changes that she made are adding workshop here on line 3 instead of backfill 2. And then if you're gonna comment this out, sometimes we've seen it where if you're running your script and you try and just comment out by putting a another pound sign or hashtag in front of it, that sometimes it'll still read that line. So your best bet is to just kind of delete it so that doesn't get read in. And then there's like save button here. So once you save it, you should be all good, I think. Let me double check. And then when you go here, you can view that same file. And this is all the contents for that file. So any questions on that? No? Okay. All right, back to you.
I think I can show you one more thing about what we talk about. So just now we have a job, and the job ID is this. If you I'll take a look at it. Let's say, I can use RCC tool, which is developed by Casey. He said there, and this is good for you to take a look of how you got the information. You can see that that is the job, and what I use is RCC2 and then the job ID, right? And from here, you can see that we have the basic information about the job you submitted. We submitted through the workshop queue, right? And from this account, and the resources we asked for. The number of cores we requested is 16, right? And the memory we requested is 16 gigabyte. This is in megabyte, but you can just divide it 1000. And this is the number of cores you actually allocated, right? And this is the memory you actually allocated. So this is what we submitted from the job script. And when you submit it and you get allocated, I will go to make some changes of the so if I comment out this line, Remember that I have already talked about it. If I do not include the total memory, how does the Slurm scheduler do the allocation, resource allocation? It will use the number here, which is the cars, times the default memory per car from the any of the accounts. So now we have workshop account. Let's see, is that any difference here? Let's try to submit the job again. We have another job. And let's use RCC2 to see active 2. You can see here, we ask for 16 cores and we do not specify the memory. So the actually memory we allocated is 62. Is the same we talk about, use this number times 3,900, right? Got the 62 gigabyte of memory. So this is something about how you can play with those parameters, right? And again, I think how much resource you ask for is totally depends on your need. So if you increase any of the things here, that means that you need to wait for much more time for the job to get started. So this is things you need to know about it. And let's get to the next section. Before we proceed, any questions so far about the job submission? Okay, let's talk about RCC support from RCC team. And as you have checked with us, we have RCC account for you to register. So if you are faculty members, the only thing you need is the RCC FSU ID and password, and you will be set. And if you are a student, you need your FSU ID and password, and at the same time, you need a faculty sponsor to a faculty as a sponsor to support your account. The faculty sponsor could be the professor in your department, the professor in your lab, anyone work here as a faculty member. Your instructors for any kind of class, and that all works. And if you are a guest, you don't have any FSU ID, and you need to get a guest FSU ID first, and then a faculty sponsor, and then you can get everything set up. This is the infrastructure we have. Our physical location is cluster held at Slurm Data Center in Innovation Park. We provide tools. And after you register for the RCC account, you have a standard RCC home directory. We have each of them will have one home directory and 150 gigabyte of parallel storage. And you also can have the shared scratch space, first come, first serve. And you have access to all of the general access queues. And you can access to the HPC system from Open On Demand and also from the command line. So if you want access to highly scalable parallel or archival storage system, or you want to have priority access to dedicated queues, or you want to customize or specialize the hardware or infrastructure, you can get additional paid features for your RCC account. And these are the general access Slurm account. And general queue, backfill 1 and 2, counter and quick test. Backfill has more powerful cores, so the maximum running time is 4 hours. And you can choose based on your need. And this is the basic software support we provided. We have software installation, configuration, and maintenance, and we provide technical support for the installed applications and software. And we have workflow process support and improvements assistant of that. And we can assist with the HPC command and utilities as well. The basic hardware support includes the data center collocation. And if you want something about software development consulting and complex or highly customized software installation, or you want some in-depth HPC and software focused consulting for research project, you can check with us for the additional support. Currently, we held more than, I think we have hundreds of softwares. This is some in different domains, such as scientific, data science, chemistry, bioinformatics, and parallel programming. And this is a list, a link to the list of the softwares we have. And I believe that the list here is not the full picture of the softwares we have. So if you want to check a specific software you have, just contact us for details. And I think some of them we can do that localized for you on your home directory. And some of them we have centralized to do that already. So for the RCC service, we have average job per year since 2022. We have 2 million jobs per year. And for the support case, we have more than 2,000 support cases since 2022. And our regular office hour is from 9 to 5, Monday to Friday. And we work hybridly, so if you have any questions, you just make appointment with us by email or Zoom. And our physical location is at Direct Science Library 151. And we highly provided you to go through this to, one is the HPC Drivers Ed. It's a series of short videos to help you get on the system. And there are specific topics that just choose the ones to look at first. And these videos, I think, include almost everything about it. And each video takes about 5 to 10 minutes, and it helps you a lot. There are a lot of demos there and some explanation there. And this is the documentation you can use. If you want to read the documentations, here's the link about that. Anyway, if you have any questions about our system, about the software you want to use, and just email us at support@rcc.fsu.edu. And this is the basic things about today's presentation. And if you are ready with it, we can do some exercise together. The first one, before that, let's stop here and see whether you have questions. Yes, please.
Is there any rules that number of hours for memory?
Oh,
No.
oh, you mean the maximum numbers of, actually, I have a link here. You can, if you do not specify, they will leave the default number there. You can check, I think here is the, yes, this is the link, default wall time. If you click the link, you can see that there are default maximum, default number of time, and also the maximum number of time you can use on that specific queue. You can show them that. So this is a link to.
So this lists not only the general access queue, which you'll see like specified underneath, but it actually lists all of the partitions. So like owners specific as well. So if you are part of a research group or a part of it'll tell you like the default as well as the maximum for
example, this is the specific queue for
right.
Some people. Yeah.
Right. Yeah. So it depends on what you have access to, and you can use the RCC tool to kind of figure out what access you already have. But yeah, I'd say this is like our go-to space that we kind of send to users so that they know how like what they have available to them.
Any other questions? Yes, please.
Let's say I want to log into RCC machines from right? So what do you can log in?
So you are able to access it. So if you're I believe if you're a grad student, but if you have access to the VPN, that's how you can log in. But also, using your RCC account, there's a specific one. There's a specific VPN for RCC users, that will allow you to have access, off campus. Yes.
Could you explain how you could run files by saving them in the directory instead? Did you say?
Sure. So if we go here, so demo 2, right, is the one that we created. So what you can do is the clusters here is the same as the terminal that Joe was able to show you on MOBA Xterm. And it's the same command, yeah. Sbatch demo 2. Oh, okay. Where did you put it?
Number 2.
Yeah. Okay. So so that's a fun error. When you get that error, that means that when I copied and pasted, there are specific line breaks in there that are not readable by Unix. And so I would have to go in and kind of delete those. But typically what would happen in this case, it would say submitted. Yeah. And then the same kind of thing will happen where the Slurm out file will also show up in that file space. And
Yes.
yeah, so you should be able to do that, like view or edit if you'd like. But yeah, so that's how, like, a non-interactive job. And I know that we had mentioned before that there isn't a difference between like submitting jobs on the on-demand versus on the command line, but it really depends on the interactivity that you want. So like on-demand automatically gives you interactive jobs, even if you kind of just leave them to run. But if you are submitting it through Sbatch, then you won't necessarily be able to see like what's happening while it's running.
Non-interactive job.
Right.
If you want to have an interactive job, just as run to a running node and then do interactive jobs. So that's different.
Yeah. The other way too that you can do, like, if you wanted to see the output to the screen as opposed to the output in like the Slurm file, is to go through RCC desktop, and then that srun command that we use, you can just run the file that you would typically run in that non-interactive space. And then the output would come to the screen as opposed to a file. Yeah.
The output comes there anyway, right?
Yes.
Right. Yeah.
With the job ID.
Right. Yeah. Any other questions? Any questions from online? Okay.
Okay. I think that you want to do some exercise before you leave.
Yes.
And the first one, I think it's quite easy. That is the open on demand. So I will leave it here and we will work around. Just let us know if you have any questions to submit the job. We just want to make sure that you can do that before you leave. And this is the first exercise. And if you can log into open demand and log in with the workshop account, and then set up a MATLAB job with the parameters here. So I will leave the page here and raise your hand if you have any questions. We can help you and we'll work around to help you.
Yeah, so just because I think the appointment is really just so that we just have to set aside time, sometimes we can figure out like it's simple, but sometimes we can also. So, and then you can also, it can be an interesting for but you know, it's, are you, this is after the next house or?
No.
Yes, I see that many of you have already successfully submitted the job to Open on Demand, and this is the step-by-step solutions for you to check later and log in with the RCC credentials, and then you choose MATLAB, and these are the parameters you need to fill in, and then you will be here to click the launch, and then when it turns to green, that means that you can launch MATLAB. And this is the page of MATLAB. Please allow 2 to 3 minutes for the fully launch. So this is something about how you can submit the jobs to Open on Demand. And after you use it, you can delete it or just leave it there to let it burn out. So this is something about how to submit a job from Open on Demand. Okay. If you do not have any questions about how to submit a job from Open on Demand, we can do something more if you want. But this is totally based on command line. So if you are not feel comfortable with, that should be fine. But if you feel comfortable about the command line, you can try. For the those who you are in person, we have already provided the TrapC and also the testjob.sh file in your workshop account. So if you want to log into that account, these 2 files are there. Otherwise, we can get started from beginning. And TrapC is the one we're going to run. And before that, we need to turn the code. We need to compile it into an executable file, which means that we can only run the executable file. So what should you do here is that if you could open the terminal, I think for this laptops, if you want, you can try the Windows PowerShell. Just search terminal Windows PowerShell, you can get to that. And I will use the okay, good. So now, did you see TrapC here? Can you see TrapC in your home directory? No? Have you ever logged into your workshop account? I think if you do not log into your workshop account, if you are in your RCC account, you need to use this command, copy the files to your home directory. This is the command you can use. And then you will be here, right? And from here, what you should do is that okay, cool. So this is the TrapC, right? As I told you that this is the code. If you want to run it, how to do that? You can first we need to module load GNU OpenMPI, and then you need to get it into an executable. How to do that? For this one, you need to do the MPIC, and then TrapC, And -o means I want to translate it to the executable file. And then you can use the name of example.x. And then this is the math library we're going to use for this one. And now you can see that there is the example.x. This is the executable file we're going to submit our job. Make sense? Any questions if you want? Since you have this example.x file here, we can use the testjob.sh file to submit the job, right? Please let me know if you have any questions so far. Yes, please. I'm sorry? Oh, yes. And this is the things I want you to write into your script, and I have already write it for you. And this is the first line, includes the shebang, and then just the basic things. We want the name of the job, choose workshop account, and the time. You can write 1 hour, that's enough. And the number of cars, and module load GNU Open MPI. And the last line is srun the example. So this is the job submission script. Any questions? Again, if you need help, just raise your hand, okay? So if you have already been here, you can submit your job to the terminal. This is how you can do that, batch. And then testjob.sh, and see your job will be queued. And the Slurm with the job ID is the one with the output. Any questions, or if you need help, just raise your hand. Again, we have already put all of the solutions in details into the slides. If you want to do that later, you can check the solutions here. And srun is the command that let the computer know that you want to run that file. That is the things you need to put it into your script. And batch is the command that let the scheduler know that you want your job to be queued. One is to queue your job into the computer, one is to run that specific executable file. But I can show you something here. Can you see the screen here? srun is something that to run this file. I can also use the interactive way to do that. Just example. So srun is like this. Just I want to run this file. Yeah. Batch is to I want to submit my job to the scheduler. Please allocate enough resource for me. Thank you. But if I just run like this, I can only use one CPU. But if you submit job in the script, I have 16 CPU size. I can show you.
The test job file has the information about
what kind of job you're handling.
Exactly. Yes.
Okay, so our MATLAB, like the actual code that we wrote in MATLAB is trapped.
Yes. You can see here, this is the job I submit just now, the one end with 111. For this one, I submit with 16 cores, and for this one, I just run directly. It has 1 CPU card.
For the MPICC track, that we were telling you to
Yes,
compile.
that is to compile it, compile the code to the, yes, to compile it into an executable file named example.x. Yes, .x means executable.
Correct.
Exactly.